1, 2, 3, 4. I want to make sure I'm actually going to be coming across clearly. I've been tweaking my microphone settings quite a bit, so I need to make sure this isn't going to sound really distorted and bad. Oh no, it sounds fine. Okay, cool. Cool. Alright. Good afternoon, friends. I hope everyone's doing alright. So, today we have a fun kit to build. It's going to be this little FM radio transmitter. So of course, beforehand, I want to talk about radio. Specifically, FM radio. FM stands for frequency modulation, and it's one of the ways that radio waves can carry information through the air. So imagine we have ourselves... That's a really terrible radio wave, I'm sorry. Imagine we have ourselves a radio wave, and and this is going to be like a span of frequencies, kind of. So we'll call this 100 megahertz. Call this 100 megahertz. So that means 100 megahertz is our carrier frequency. And in an FM system, that means it's the center frequency. And if we were to look at this on an oscilloscope, we would see like a center line here at 100 megahertz, and the wave on either side of that line would do kind of a motion like that along with the audio. Right? So it's modulating this frequency. It's slightly changing it based on the information that it's carrying. And that's, well, that's kind of it in a nutshell. I don't have a really nice way to show you that, mainly because I don't have a way of really generating an FM frequency, and because the oscilloscope I have is basically a toy. But what I can show you is something kind of similar. Let me just get this going here. Come on. Wakey. Well, this is the joys of doing things live. Nope, that's not what I want. Go away. The joys of doing things live. And, oh, copyright infringement. Alright. So what this display is showing you is we have a center frequency here at 95.5, and this is showing you a band of frequencies, and it's just showing you the level of each frequency that's across this range. And we can see we have 95.5, and it's going all the way up to like 95.6 and down to 95.4, and we can see there's just, you know, frequencies jumping around all over the place there. Now I'm using a wireless microphone, and I happen to know that my wireless microphone here runs at 195 megahertz. So we can see the carrier frequency here at 195, and we can see it modulating the frequency with my voice. Pretty cool, huh? Of course that, and yeah, we can see that carrier frequency is in the center. There we go. You see the carrier frequency is in the center. It's modulating the frequency off to either side of it. And actually, if we were to actually listen to this, it would actually be carrying my voice. But I would also make a really terrible noise. Can you even see that? Oh yeah, you kind of can. You can also see my light very brightly in the screen there. I'm sorry about that. Anyway, hopefully that's interesting. So now we kind of understand what an FM broadcast is. So we kind of understand what an FM broadcast is. In a nutshell. So let's go ahead and pull out our kit. They gave us a little audio cable, a piece of wire for an antenna. And we have a very nice printed circuit board. Some resistors. And we know that these are carbon film resistors because the body of the resistor is beige. We have a few different values here. Now this green one is not a resistor, it is an inductor. We have a couple of different inductors in here. Now what the heck is an inductor? I'll get to explain that one too. So we might remember we have a capacitor. What a capacitor does is it stores and releases energy. And what an inductor does, here's another inductor. What an inductor does is it resists change. So an inductor doesn't really want to change what it's doing or what the circuit around it is doing. But if we put an inductor and a capacitor together, we get an oscillator, because it's going to try to oscillate at a specific frequency. And that is actually how the tuning on this transmitter works. You'll see it. So we have a set of switches here, and what it's doing is it's using these switches to switch in different inductors and different capacitors to tune the circuit. Pretty cool. Now then, I'm going to put the resistors out of the way here. And the main thing in this circuit is this little chip right here. Oh, that thing. I'll very carefully zoom in here. Oh, look how little that guy is. Well, so this is what's known as a surface mount device, SMD. So you see all these other devices have long leads on them, and these leads actually poke through the holes in the circuit board, like that, yeah. But an SMD part is going to be soldered directly to the board, and these are quite a bit more difficult to solder, typically. And the kit wants us to start with that. So I'm actually going to stay zoomed in here. I'll put that there. Well, you know what? I lied. I'm going to zoom out. Going to zoom out. We want to sort our parts out here first. 470 microfarad, 16 volts. Another one of those. We have an LED. Have our dip switches. The power terminal. Yes. We have a 222 picofarad capacitor. It says 222 on it. We have 30 picofarads. I have another 30 picofarads. 104 picofarads. Oh, we have 1 microfarad. And yeah, we're going to have a few of those. 1 microfarad capacitors. This is 47 microfarads. Okay. That's 10 microfarads. Yeah, there we go. There's another one. There's our audio jack microphone. We have a crystal oscillator here. Have our inductors. Little transistor here. This is S9014. Okay. Ooh, now that thing I'm going to talk about a little bit more. 222. What's this one again? 104. 104 there. Have a 102. Little switch. 101. 101. 30. Talk about that. Have another S9018. Okay. 1 microfarad. 10 microfarad. Is that this one? Yes. Okay, those two are 10 microfarads. And 22 microfarads. Same transistor. And 4 of those in total. Another little switch. 30. 30. 103. Okay. 102. Okay. 104. Let me put that over there. 15. I'm going to have to start finding more places to put things. 103. Some of these are quite difficult to read. 22. I don't think I had a 22 pile yet. 101. 101 there. 104. 104. There we go. Now then, I set aside 2 components here. You can see the kit designers were very kind to make one with bent leads on it and one they left straight, because these are 2 different things. They're both diodes. However, one of them is a Zener diode and one of them is a varactor diode. Which one's which? I'm not sure which one's which. ZD 4.3 volt. Okay, so the bent one is a Zener diode. So what a Zener diode does is it wants to have a voltage across it, a certain voltage. In this case, it's 4.3 volts. So it will change its resistance in order to have that voltage across it. And that lets it be used as a voltage regulator. Now the varactor diode is kind of the same deal, except it's capacitance. So this will change its capacitance. I'm actually not sure how. I'm actually not very familiar with varactor diodes. Never had a project that used them. I've used Zener diodes before, though. Anyway, now we have our stuff sorted here. We wanna solder this chip. Oh, excuse me, just having a quick drink of orange juice there. I'm going to use my flux pen. I'm going to zoom in here. Yep. So I'm going to use my flux pen. I'm going to put plenty of flux on these pens. Just like that. So, a little review. What do we remember about soldering? Remember that this is solder, and this solder is a hollow tube, and inside of it is flux. Because solder wants to follow heat, and flux is what enables it to follow the heat. Now normally for all the rest of the components, just the flux that is in the solder is going to be plenty. However, with our surface mount device, we're actually going to use the flux to guide the solder. So now we've got our device here, and we see there's a little spot on it. That spot is pin 1. And if we look on the board, we see there's a picture of the chip, and at one end there's a little notch. That notch is the end where pin 1 is. So we want to align it kind of like that. Now what I'm going to do, I'm going to get my soldering iron. I'm going to put just a kiss of solder on pin 1 and pin whatever that is. Opposing corners. So I've got opposing corners. I'm going to add more flux to that. Make sure I'm staying in frame. I'm going to align our chip. I'm going to hold it while pushing in that corner. I did kind of a poor job of that, actually. It's okay. There we go. I'm going to kind of do the same to this corner. Kind of get that to hold on. we go. So now we have our chip tacked in place here. And what we're going to do, because we have plenty of flux on the board, and actually you might have noticed that the board was kind of sticking to my finger, it's because that flux is very sticky. So I'm going to be able just kind of put a glob of solder on there and drag it along the pins like that. Put a little too much on there. So I'm just going to clean off my iron real quick. I can reheat that and kind of redistribute it. I want to make sure none of our pins are touching. That looks pretty good. And that method is called drag soldering. The other option is we can go through and solder each pin one by one. You know, do whatever you feel comfortable with. Either way, our chip is soldered. See how easy SMD can be? Don't worry, it gets insanely difficult. This is a relatively easy board to solder on. I'm just gonna inspect that. Make sure it's all okay. It all looks good. Okay. So now, I want to start with our lowest components first. And the instruction sheet is just one piece of paper here, and it wants us to do the diodes. We have the spot for our Zener diode, and then we have the spot for our varactor diode. I'll zoom in here again. Go. We can see the picture here has like a little arrow pointing to a line. If you remember, here we go. We want that arrow is pointing towards the black line. So imagine that arrow pointing this direction. Right? Let's go ahead and put in our Zener diode. Just like that. And then got the same thing with the varactor diode. I'm going to put that on its back like that. We'll bend the pins down. And we'll insert this into the board, like so. Kind of splay the pins out, and that holds the component in the board, just like that. Yeah, make sure we're Still staying centered there. See if anyone's chatting at me real quick. Okay. We want to get just a little kiss of solder on our iron. That helps the heat transfer. And then we want to be touching the iron to the lead and to the pad. And we touch some fresh solder between there. Just like that. Did you miss it? Here's another angle. Just like that. That's going to solder our component down. There we go. Where'd my cutters go? I just had them here. This kit's going to be pretty hard to put together without cutters. Oh, there they are. There we are. Now then, so I did want to point out something on here. We can see on this kit, it says it calls for a 4 to 6 volt input. Now that's this chip. That's taken directly from the data sheet for this chip. This chip is designed to work on 4 to 6 volts. My question to you is, why do you think that is? I think I know. I think there's two possible answers. And if anyone can tell me those answers, I will confirm or deny them. So I think there's two possible answers to that question. Both are equally valid. It has to do with the possible applications of this chip. Can I put this somewhere where you can see it? That is the question. There we go. So apparently this is the only multimeter I have that's actually clearly visible on the stream and not painfully slow. So we want to test these diodes here. You can see these are 2K diodes. So that one's 2K, 2K, 2K. There we go. 2K. There we go. What the heck? That was weird. Just shut down on me. Huh. Okay, well, set that meter aside for a minute. So we're going to go ahead and solder in all these 2K resistors. I almost called them diodes. Well, so where are we putting 2K diodes? I'm sorry, no, they're 2.2K diodes. Diodes. I keep saying diodes. They're resistors. They're not diodes. They're completely different. So our PCB here is very clearly marked with what values go where. Makes this kit kind of easier to assemble. Yep. And resistors, unlike diodes, don't actually care which way you put them in. However, it looks a lot nicer if they're all going the same way. Just looks nicer. Purely aesthetic. There we are. And let's see. A couple more places for these. Is that one there? Ah, okay. You do kind of have to hunt and find for where things go. That's okay, it's part of the fun. This kit doesn't give you any spares, so we know when we've placed all the components and we don't have any left. So it makes it easy to figure out, you know, if you have an extra resistor, well, that means there's a place to put it. I'm going to put you in like that. There we go. We're going to go ahead and solder those down. So has anyone figured out why the voltage range might be 4 to 6 volts? One of the two reasons? No? I think one of the reasons is USB is right in the middle of that. USB is 5 volts. So this will run from USB just fine. That was the easier of the two answers. Yeah, I should have told you the harder of the two answers. Maybe you can guess it. I'm just cutting the leads off. There we go. Next batch of resistors. What's this one? This one has a purple band on it. Where you can see it. What do we have here? We have 5 ohms, or 4.7 ohms. We're going to call that 4.7 ohms. If I can actually pick it up, that'd be helpful. So where do we have a 4.7 ohm resistor? Ah, right at the top. There we go. Perfect. Let's just grab one at random here. We have 100 ohms. Okay. I think those are supposed to be 100 ohm resistors. So where are we putting 100 ohms? Nope. Here's one. Gonna make sure it kind of looks same direction there. There's the other 100 ohm resistor. Here it is right here. So we're gonna pull that off. There you go. 100 ohms. So I figured out the other reason why the voltage range might be 4 to 6 volts. I think if you have 4 nickel metal hydride batteries, fully charged, they're going to be about 6 volts, and fully depleted, they're going to be about 4 volts. So I think they intended this to run from nickel metal hydrides. A simple little 4 battery pack there. Let's test some more resistors. And 4.7K. Come on. 4.7K. There we go. Two 4.7K resistors. Okay. Could have sworn there are more than 2 places for that. 47. 0.7, 4.7. Oh, I guess not. Okay, well. Yeah, I guess there's only 2 places for 4.7K ohm resistor. Lots of 10K resistors. Alright. Good enough for me. Well. So, I was actually reading the data sheet for the main chip on this board, as one does. Why might it be intended to run from USB or from a 4-pack of nickel metal hydrides? Well, it's an FM transmitter chip. They intend it to be used in communications. So 4 nickel metal hydrides makes a nice little rechargeable battery pack for a little portable radio transmitter. 5-volt USB, makes very convenient, like a car transmitter. Like you could use this in a car. If you didn't have a tape input, you could plug an MP3 player into this and broadcast a mini FM radio station. It's just a very convenient way of doing that with this chip. Go. We've got 47K. Yeah, I think that's our 47K resistor. Not to be confused with 4.7. Let's see. What's the other 47K resistor here? Oh, there it is. Way over there. There we go. Just like that. Go. And I'm gonna actually go ahead and fit this inductor here. Figure out where it goes. It goes right here, where it says, zoom in here to it, so I can show you the difference. Come on, focus. Focus, focus. Come here. Come back to me. There we go. I guess that's the limit of how much I can zoom in. So, I'll show you what this looks like. We can see resistors are marked like 10 and then K. However, this inductor is marked 150 UH. That stands for microhenries. Because all these measurements are named after people and Henry would be his last name. Just like ohm is someone's name, farad is someone's name. It's all based on things they discovered. Electrical properties. Well, there's our inductor. Now I've got a ton of 10K resistors. Quite a lot of them. Oh, I'm gonna put my multimeter where you can see it. Oh, that one's good. That one's good. That one's good. That one's good. 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 We're good. We're good. Good there. Good there. Good there. We're good there. All right. Alright, now we got lots of 10K resistors to put in. I'll put these in all the places where it says 10K on the board. Well, what can I talk about that'd be interesting, huh? There we go. So you see here at the top there's going to be like a bank of 10K resistors. This is all for tuning those circuits with the capacitors and the coils to finally adjust the frequency between them. 10K is just a nice round value to use for that. Makes it easier to calculate the needed values for the capacitors and the coils, the inductors. That's all an inductor is. It's a coil. Makes it easier to calculate the needed values for that when the resistor value in the circuit is just 10. Alright. Oh, I see where we're putting the last two. Oops. There we go. And we know we're done placing 10K resistors because there's no more left. That was the entire package. I'll zoom in here, maybe a little more interesting. Oh. Because we're using lead solder, it'll cool with a nice shiny finish. Don't worry, the smoke that comes off of this is not lead fumes. You won't get cancer from breathing it. The smoke is from the flux, which is also not good for you. And, you know, don't intentionally be huffing it, but I think it's slightly less bad than the flux you would use with lead-free solder. So there's that. There we go. There we go. Ah. Nasty. Okay. There we go. Oh, well. That one looks ugly. Oh well. No big deal. So now, we have soldered all of our resistors. How about that? What does the instructions want us to do next? It wants us to do coils. It wants us to do these coils. Okay. So now while these are marked, so these are inductors. They're just a different type of inductor from the 150 microhenry one. Because these are just like big turns of wire, like it doesn't even register as like a picohenry. So instead, they're marked with these boxes here, and you see where it says L2 8T, and it says L4 5T. So that just means it's 5 turns and 8 turns. We can see that one of our coils fits right in there because it has 5 turns on it. Fairly self-explanatory, that one. Gonna bend the leads to hold it in place. We'll install our 8-turn coil. Do the same thing. Alright. Well, focus. Alright. Now these, you really want to hold your finger over them when you're cutting them, because they will go flying across the room, and they are magnetically attracted to eyeballs. Very unpleasant. And now we have an LED. The LED. We can see on here how it's marked. You can see that one section of the board is slightly darkened, and we can see that it's going to like the main light green area. So that means this is the negative side of the LED. And indeed, our instruction sheet confirms that. So we want our LED to go in like that. You can see how one lead is slightly shorter. So we want our LED to go in there. Just like that. Ah, yes. There we go. Focus. Oh, makes a lovely burning semiconductor smell. Mmm, tasty. And now we have lots of capacitors. Lots of little ceramic capacitors. So we got 104 right there. We've got a 30 here. Another 30 right next to it. $103 right here. Go 104. Well, actually, I picked up a 102, so this might just have to be kind of thing where I pick up a value and stick it where it goes. 102 right there. And I picked up a 101. Where does a 101 go? It's a 104. Oh, there's one. Right there. Some of these are slightly difficult to read. Let's do another 101. Right there. Not sure I missed that one before. How many more 101s is there? Da, 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 da. 22, 3. Oh, there's a 101. Right there. There we go. 102. It's a 104, 104. It's 3, 30, 104. Oh, there it is. Right there. And this is 103. Let's see, I know I just saw 103. Oh, there it is right there. So this type of capacitor doesn't matter which way you put it in. Oh, it'll be fine either way. Let's see. I'm going to actually go ahead and solder those in before this gets too messy and difficult. There we go. There we go. Those pieces installed there. There we are. Get those guys soldered in place. Making a mess of my work area here. Oh well, it's okay. That's what it's here for. Just kind of brush. Ow. Ow, ow, ow. Ooh, ow. Okay, maybe try not to brush things off. Oh well. 222. There's lots of 222s here. That guy put in place. Another one right here. There we go. I've got a 104. A couple of those. And, oh, there it is, 104. Right there. And we'll do, whoops. Don't lose any. 30 right there. There we go. And 30, another 30. Right there. And this is 104. It's another place to put a 104. 15, 30. Where is it? Where do you go? I'm actually not seeing it. Uh-oh. Oh, there it is. Found it. Right there. Crisis averted. And 30. Oop, uh-oh. I made a mistake. Okay, I accidentally filled in a hole with solder that I did not intend to. I didn't notice that before. Okay, well, deal with that in a second. This is... what is this one? 22. Where does 22 go? Oh, there it is. Very corner. There. We have 15. Uh-oh. I'm missing a capacitor. That's not good. I am missing the 3 picofarad capacitor. Where could it have gone? Well, hopefully it's not important. Trying to look through the little plastic baggies, because the 3 picofarad capacitor is going to be pretty small. Did it fall on the floor, maybe? Maybe it fell on the floor. No, I'm not seeing it. Okay. Well, hopefully it's not important. We'll find it later. If it doesn't work, we'll know why. Oop. There we go. Alright. Now let's see what's going on around this 3 picofarad capacitor. Oh, it's in it's in one of the circuits for the tuning. Oh man. Yeah, it's going to be an important capacitor, isn't it? Oh well. Anyway, let's fix the problem we created with this 30 picofarad capacitor where I accidentally filled in the hole for it. You can just clear the hole. No. Yeah, that happened when I was drag soldering the chip. Oh darn. Let's not get in a situation where we're about to touch the iron. That usually ends quite poorly. And now I'm going to end up spending a bunch of time fixing my mistake. Yeah. Oh well. There it is. It's in there. Making a pleasant smell. What's next? Yep. Want to solder in our switches. And the instructions are showing it going in like that. And to install crystal. There we go. Oh, come on. switch soldered. And let's see. And we can do our transistors. You can see how the markings on the circuit board here kind of outline the actual physical shape of the transistor. Tells you how to put it in there. That's good. Oh. There we go. I don't want to spend a whole lot of time with heat on transistors. They're somewhat sensitive. So you kind of want to touch and go with these. There we go. This is another thing where the leads are pretty thick, and when you cut them they will want to ping across the room, which is very unpleasant. I have a question about the flux pen here. A quick question about the flux pen. When you first get these, you need to actually push the tip in, like really push it in, and you'll see the tip turn orange there as it soaks in. There we go. Now my finger's covered in flux. Let's see. Let's install our big capacitors. So now, with these big guys here, yonk, zoom right in there. You'll see on the PCB we have a marking here. We have a shaded side, and we have a side with a positive. And on the capacitor we have a negative marking, no positive marking, but we have two different sizes of legs, and we want to put these in like that. So, big old capacitor. Reason for that is this type of capacitor does care which way you put it in. So, And they can be violent if you put them in wrong. Let's see. And then we have just kind of a row here. That's a 47 microfarad. And 10 microfarad. 10. Just going to go up a line here. 1. Or 1 microfarad capacitor. Another 10. 10 microfarad. My fingers are really sticky now from that flux. 1. No. 1 microfarad. And just verifying. 1 microfarad again. And 1 microfarad capacitor up here. Taking very careful note of which way the pins are going. And our 47 goes right here. Uh, 22 goes right there, so this is a 22? No, that's a 1. Oh, here's where it goes. Our last 1 microfarad capacitor. That means this must be a 22. Or is it? Yep, 22. Okay. Yep. There we go. We're just going to kind of solder these down. I heard something go click behind me, and I'm not sure what it is. There. Make sure. Oh, double check stuff. Okay. There. Now we have all of our capacitors except for the one that I lost. We'll go ahead and put these switches in place. These guys, it doesn't really matter which way they go. You'll kind of feel them snap into the board. Kind of satisfying. The two outer contacts of them are actually the shell, and they're going to be slightly more difficult to solder because they're going to absorb a lot of heat. And it's a bigger hole, so it's going to take more solder to fill it. I felt something hot. I don't know how, though. There we go. Cool. How hot. And they stay hot for a while. Let's see, do we want to do the microphone? Yeah, I guess so. So, microphone. Kind of line it up with its picture on the board. What I'm going to do is I'm going to kind of tack it in place, one of the legs. I'm going to push on it while soldering it. I'll make it nice and flush against the board. There we go. We'll put in our audio jack. I'm going to bend out. Well, maybe not. Bend that pin up a little bit. Bend out the outermost pins here just to hold it in place. Why are these so hard to bend? Maybe I won't because they're hard to bend. I'm going to do the same thing. I'm just going to put kind of enough solder on there just to hold it. I'm going to remelt it while pushing on the back side. And that'll hold it in there. And again, these are big pins. They're connected to kind of large pieces of metal, so slightly difficult to solder. There we go. Then we have our power terminals. Yeah. That should do it. There we go. That's not going anywhere. Yeah. Oh yeah, looking good. Oop. Nice. Now let's do our antenna. Our antenna's the last thing. I'm just going to strip a little bit off the end. Come on. Come on off there. There we go. So what I'm going to do here is actually feed it up through this hole and poke it down into the antenna hole there. Kinda use that as a bit of a strain relief. This antenna wire. Just like that. I think that's a finished kit right there, except for that 3 picofarad capacitor. You know, that's bothering me. I need to look for it more. I need to look more for that 3 picofarad capacitor. So it's really bothering me that I don't have it. I'm certain, you know, it probably pinged off when I was opening the package. So I know I opened this package previously and I went through and cataloged all the pieces, made sure they were all there. Or did I? You know, maybe I was missing the 3 picofarad capacitor all along. Did you guys see where it went? Maybe I'm crazy. I think maybe I'm just crazy. Maybe I never had a 3 picofarad capacitor. Well, maybe I have another one from another source here, though. Let me see if I can check another source. So, no capacitors at all. That's weird. Well, you know, something, because I have a feeling that capacitor is for one of the tuning ranges of the transmitter. So if that range doesn't work, I at least know why, and I can fix it later. But for now, I want to see this thing work. I want to see it transmit something. Okay. I want to see this transmit something. But first, I'm going to clean up my area here. I'm going to just take this whole mat and just go over to the trash can and put all these things in the trash can. Get off of there. Get off. Get off. Yeah. All sticking to it. There we go. There we are. Okay. So, let's see. With all of the switches turned off, it should be broadcasting at 87.7 megahertz. Okay. So, let's get our tablet back over here. Where'd my tablet go? There it is. Boop. Three people unfriended me? No way. Well then. What the heck? Oh. So we want 87.7. Come on, come on, come on. Bah. 87. Let's go. So it should be somewhere around there. Oops. There. Okay. And we want to make sure we're doing this right. Let's see, if I had a couple pieces of wire to stick in there, it would work a lot better. Do I have a couple little pieces of wire? Maybe not. Wait. I guess I should have thought about this beforehand. You know, I'm just going to use a couple pieces of solder. There you go, I got plenty of solder. And a little screwdriver. Let's stick this up there. So now we can loosen that up. Actually, you know what? With those loosened all the way up, I think I can actually just clip this right on there. Just like that. See if that works. Power on. Do we get anything? Yeah, we got something like right there. Is that it? Yeah, it's something. Oh, you know what? I was in the wrong range here. You know, our low range might not be working. Our low range might not be working because of that capacitor. So let's try doing low range might not be working because of the lack of that capacitor. So let's try doing 107, 107. Can I 107.3? Do 107.9 maybe? Okay, I can do 107.9, looks like. So let's try 107.9. Low, high, high, high. Oh, 7.9. Oh. it's doing something. It's doing something interesting here. I'm not totally sure what. Yeah, let's try. Let's try connecting some music to it. Yeah? Let's find some music to play through here. And, see what we can do. Something's going on here. Let's... this is being weird. Alright. I'm not sure if mine's working, actually. Low, high, high, high. Yeah, it should be 107.9. Yeah, we're not actually getting anything from there. Uh-oh. I might have completely failed to make this. Either that, or our 3 picofarad capacitor is very important. Oh, gosh. I think our 3 picofarad capacitor might be more important than I thought. It's like connected right to the middle of that range switch. Yeah, something's not. Well, mine's not working because I seem to have lost that capacitor, which turns out is very important. Alright, well, so lesson learned, don't lose that capacitor. So I'm going to have to find another capacitor to stick in there. Darn, 3 picofarads. That's going to be a teeny tiny little capacitor. Well, anyway, I guess I can reveal my other thoughts for this. I have a USB cable. This is like from a dollar store, so no real harm done in chopping the end off of it. There we go. We don't need the green and the white, so we'll just get rid of those. And we can strip the red. and the black. Alright. I'm going to actually put a little bit of solder on these just to make them a little bit thicker, a little easier to work with. Also mean they won't come fraying apart. Huh? Yeah, there we go. We can shorten those down a little. There. Where'd the screwdriver go? There we go. There we go. So I'm going to have to find a 3 picofarad capacitor. Other than that, that's how you put these things together. And now with the USB on there, plug it into a power bank. There we go. You can run it from a power bank. Yeah. Anyway, thank you for watching. That's all for today. We built a radio transmitter and it didn't work because I lost a capacitor. I'm probably going to find it later after I've ordered another one. And then I can kick myself. Oh well. Thank you for watching. Have yourself a wonderful day.